Hello there, my name is Daniel Wilson. I'll be your host today, and on behalf of all of us at SpaceX, I'd like to welcome you to our opening of the Piccard Mission. We got a lot of things that we're excited to share with you, and we have the pleasure of inviting some of our specialists on the stream today to give you greater detail on the mission. But before we get too specific, let's talk a little bit about what we're going to be doing today. Named after Jacques Piccard, the first to explore the bottom of the Marianas Trench, the Piccard mission seeks to break new ground, diving to never-before-seen areas. The mission will start on the Martian surface, where the Falcon Heavy will launch our probe into space, sending it on its way to its final destination, which is Titan. But first, a little bit about Titan. One of Saturn's moons, and the only moon in our solar system with a substantial atmosphere, Titan holds many mysteries that Piccard is intent on solving. This cold moon has an average surface temperature of negative 179 degrees Celsius, which allows methane to liquidize and causes rain and seas. Titan's largest sea, Kraken Mare, is located near the northern pole, and it's our focus on the Piccard mission. These methane seas and hydrocarbon atmosphere makes Titan a high-interest location for other life in the universe. And due to the fact that Titan has so much organic material and appears to be producing methane, some speculate about the possible bacterial life in her seas. Titan's surface varies between rocky surfaces and dunes made of solidified hydrocarbons resembling sand, but observations of it are obscured by the atmosphere. So we'll be learning a lot. From Piccard, we hope to learn about the formation of life in our universe, possibly expanding our views about what habitable areas within our solar system look like. In analyzing sea composition more closely than possible from orbit, we may even find life. If not, however, we'll get a better understanding of the history of Titan, as this would reveal information as to the sources of Titan's methane when compared at different depths. And to test if the organic molecules are actually coming from the moon's core or if there is something within the ocean creating it. Titan may be hiding much more than we expect. By analyzing the currents in Kraken Mare, we hope to get a better understanding of Titan's methane cycle, which appears to be similar to our water cycle on Earth, which could in turn give us more information about what human colonization of Titan would look like. Finally, we'd like to achieve something that's more intangible than the rest, but no less important, which is the inspiration of the masses. As with the plan of private space companies and Martian colonies, the realization of fantasies has inspired and driven people worldwide to create a better future for all. We hope Piccard can have some part in motivating the engineers and physicists of tomorrow as we continue to seek knowledge of our solar system. But before any of this can happen, we need to get our probe off the ground. For that, we'll need Falcon Heavy and Stefan Jacobson, our head of engineering, for some insight and information about our flight. Stefan?
Thank you, Daniel. I'd love to go over the flight with you. Now, I'll be going over the 3 phases of the flight: the launching, the journey, and the landing. Now, since we're launching from Mars, we're going to have to take into account the different mass and radius as opposed to Earth. The launching of the probe will be done on the 1st of October in 2020, and the planned landing will be in the 17th of August in 2027. The launching process takes into account a Falcon's weight, being 1.417 million kilograms. The escape velocity turns out to be 5,014 meters per second, and the binding energy is 1.78 times 10 to the 13 joules. But in this flight, we won't be leaving the gravitational field of Mars and heading straight to Saturn's moon. We'll be using the Hohmann's transfer orbit to reach Mars. To reach Saturn, I mean. The Hohmann transfer orbit is an elliptical orbit around the celestial body, in this case being Mars, and letting the probe travel along it to pick up speed, and the fuel cost will be much lower because we won't be having to fight against the gravity of Mars. Going along this path will allow the probe to reach Saturn orbit in around 2,389 days, or 6.5 Earth years. And there's 2 points in this journey that will have to change the velocity, this being when we exit Mars's orbit and when we enter Saturn's orbit. Now when we leave Mars's orbit, there's going to be a decrease in velocity by about 8.998 kilometers per second. And once we enter Saturn's orbit, to fully go into its orbit, we need to increase its velocity as a boost to get in. So that'll be an increase of 7.162 kilometers per second. Now the difficulties we might face along the path are Jupiter and the asteroid belt. But with Jupiter, we scheduled the launch window so that we won't even have to deal with Jupiter on the pathway there. And the asteroid belt, well, we don't really have to worry about that since there's not really that many documented cases of there being any crashes in the asteroid belt, since there is a lot of asteroids, but they take up so little space that it's not really a problem to think about. Now, once we enter Saturn's gravitational field, this is where we'll be using a figure-8 path to enter Titan's atmosphere. We're going to be going around Saturn and then balance that out by going into Titan's atmosphere. By using the Saturn's pull, we can allow ourselves to slower descent while also saving on fuel, because we won't have to use the fuel to slow us down. And after we enter Titan's atmosphere, since the atmosphere is so dense, we can use the orbital maneuvering systems engine, where we'll use Titan's atmosphere to slow us down, and once we lower ourselves down to less than the speed of sound, we can then maneuver ourselves towards Kraken Mare and then deploy the parachutes where we can safely contact with Titan. Back to you, Daniel.
Thank you, Stefan. As just mentioned, the Piccard probe will use parachutes to control its descent down towards and hopefully into Kraken Mare. Since the atmosphere of Titan is thicker than Earth's, with only 13% of Earth's surface gravity, Piccard will have greater control over its descent through the atmosphere. At this point, Piccard will deploy its parachute, which will guide it down towards Kraken Mare. This parachute is designed on the same aerodynamic principles that guide military payloads to points based on GPS data. However, Piccard will not have this luxury. Instead, it will seek out Titan's northern pole, discernible to the probe due to the moon's rotation, and once within visual sight, seek Kraken Mare out, aiming to touch down on the sea itself. As difficult as this appears to be, it's not entirely unheard of, as the New Horizons probe used optical navigation to plot its course adjustments as it approached Pluto. This type of maneuvering is inherently imprecise, as weather is unpredictable on Titan. So even if the Piccard lands outside of Kraken Mare, we've included retractable wheels on the bottom of the craft, allowing it to crawl towards Kraken. Once Piccard arrives at Kraken Mare, the probe will slowly follow the shoreline, using images captured by satellites previously to guide its journey. It will complete or lap around the inside of Kraken Mare, creating a database of locations for it to refer back to and connect additional places on its virtual map. Once this initial step is completed, Piccard will surface and transmit the data by raising a 12-watt high-gain antenna, like used on the New Horizons mission, located on top of the probe, staying at the surface for weeks as the data is transferred. During these points, Piccard will continue to collect data about Titan's weather, as we'll have the opportunity to observe the events from a single location, leading to a more complete image of what weather on Titan would be like. Once transmission is done, Piccard will continue its spiraling path along the shore, moving closer and closer to the center of the sea with each iteration. In doing this, Piccard will be able to attach the mapping data to the previously mapped areas, creating a comprehensive model of the sea. While Piccard makes its voyages in the frozen sea, heat from the nuclear reactor will keep it and its instruments through pipes within the sub. During its travels, Piccard will be collecting data and attaching to it the location and time it was collected at, allowing our scientists to view trends in the sea. Fortunately for us, in the construction of Piccard, we didn't have to worry too much about the pressure we'd be under, as at the deepest point in Kraken Mare, which is around 300 meters below, the pressure is equivalent to only around 28 meters below Earth's seas, which is well within reach of civilian-grade technology. Obviously, though, the development of this technology still came at a cost. So for more information, we'll go to our Chief Financial Officer, Rajivan Chalia. Rajivan?
Thank you, Daniel. I'm very excited to share the financials of Piccard, as I believe we have achieved something extraordinary today with our launch. The delayed Curiosity mission ran a tab of $2.5 billion. Cassini-Huygens, which included a lander sent to Titan, cost in excess $3.2 billion. Piccard is expected to cost us less than $939 million. This price includes the development of a marine mapping probe and operation costs for the duration of its 2-year mission on Titan, as well as its transportation. The Piccard mission will only cost $90 million to launch, which is less than 1/10 of the price of the Curiosity mission paid to launch between Earth and Mars. This is due to the reusable nature of the Falcon Heavy. The Piccard probe cost us a total of $687 million to design, while the construction of the probe itself only cost us $141 $5.4 million. Included in that cost are the experiments designed by teams throughout the world, which themselves took $16.9 million to complete. A small trade for the information they will provide us. Working with Google, new mapping software was developed that gives us the ability to accurately navigate and record Kraken Mare's subsurface topography. This collaboration of technology comes in at $92 million. We expect the cost of operation over the mission's planned length to be $312 million for the 2 years, as our scientists receive and analyze data as well as interact with Piccard. Trailblazing like this comes at a cost, and our ability to connect all of these new technologies almost reached $1 billion. But we feel it's money well spent. Back to you, Daniel.